Hello students, welcome back to the fifth lecture on Poisson distribution. In the previous class, we have solved some examples on Poisson distribution. Today we will solve some more examples on Poisson distribution. Today's first example is in a textbook on an average 0.3 mistakes per page is found. If there are 500 pages in that textbook, in how many pages there will be? First sub question is 3 mistakes and second sub question is at the most 2 mistakes. Read the question carefully and what is given that we will denote by the notations. In the solution, we have to denote, let x denotes the number of mistakes per page. Let x denotes the number of mistakes per page. Thus, x follows a Poisson distribution with parameter lambda equal to 0.3 and here n is equal to 500. You can read the question. On an average means 0.3. It is a mean or lambda or parameter of Poisson distribution. So lambda is equal to 0.3 and there are 500 pages in that book. So capital N is equal to 500. Therefore, the PMF, that is P of x, is equal to e raised to minus lambda into lambda raised to x upon x factorial. That is e raised to minus 0.3 raised to x upon x factorial, where x equal to 0, 1, 2, so on infinity. Therefore, we will solve the first sub question, that is probability of 3 mistakes. We have denoted x as number of mistakes. So 3 mistakes. 3 mistake means probability of x is equal to 3. Now we have to put x equal to 3 in this probability mass function of Poisson distribution. So which is equal to e raised to minus 0.3 as it is, 0.3 raised to x. So x is equal to 3. So 0.3 raised to 3 divided by x factorial, here x factorial. So x is equal to 3. So 3 factorial. Now e raised to minus 0.3, this value you will get from statistical table, Poisson distribution table, that is 0.7408 into 0.3 raised to 3, 0.3 raised to 3 is 0.027 divided by 3 factorial. 3 factorial is 3 into 2 into 1, that is 6. And if you simplify this further, then you will get 0.003333. Now they ask that number of pages. So therefore the number of pages with 3 mistakes are equal to capital N into probability of x equal to 3. Now capital N is 500 into probability of x equal to 3 is equal to 0.003333. You multiply this, you will get 1.66. Now 1.6 is nearly equal to 2 pages. That means the number of pages with 3 mistakes are 2 pages. This is the first sub question. Now come to the second sub question, that is probability of at the most 2 mistakes. Now at the most 2 mistake means probability of x less than equal to 2. Probability of x less than equal to 2 means probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Now in the PMF we have to put first x equal to 0, then x equal to 1 and then x equal to 2. Now first we will put x equal to 0. E raised to minus 0.3 as it is, 0.3 raised to x and x here it is 0 divided by 0 factorial plus e raised to minus 0.3 into 0.3 raised to 1 divided by 1 factorial plus e raised to minus 0.3 into 0.3 square divided by 2. So e raised to minus 0.3 from statistical table is 0.7408 into 0.3 raised to 1 is 1 divided by 0 factorial is 1 plus e raised to minus 0.3 is 0.7408 into 0.3 raised to 1 is 0.3 divided by 1 factorial is 1 plus e raised to minus 0.3 is 0.7408 into 0.3 square. 0.3 square is 0.09 divided by 2 factorial is 2. If you simplify this, then you will get, first simplification you will get 0.7408. This second simplification you will get 0.2222, and this last simplification you will get 0.033336, and if you add these all, then you will get 0.9964. Therefore, the number of pages with at the most 2 mistakes are nothing but capital N into probability of x less than equal to 2. That is 500 into 0. This probability 0.9964. If you multiply this, you will get 498.18, which is nearly equal to 498 pages. That means the number of pages with at the most 2 mistakes are 498 pages. Now let's move to the second question. The number of accidents in a year attributed to taxi drivers in a city follows a Poisson distribution with mean 2.5. Out of 1000 taxi drivers, find approximately the number of drivers with one accident in a year. And second sub question, more than 3 accidents in a year. Now according to the given values, we will denote the notations. Let x denote the number of accidents attributed to taxi drivers. Let x denotes the number of accidents attributed to taxi drivers. Therefore, x follows Poisson with lambda equal to 2.5. It is given Poisson distribution and mean is 2.5. So for Poisson distribution, mean is nothing but lambda, that is parameter. So x follows Poisson distribution with lambda equal to 2.5 and n is equal to 1000. Therefore, the PMF is P of x equal to e raised to minus lambda into lambda raised to x upon x factorial. Now we have to put lambda equal to 2.5. So e raised to minus 2.5 into 2.5 raised to x upon x factorial, where x equal to 0, 1, 2, so on up to infinity. Now we will solve first sub question, that is probability of one accident in a year. So probability of one accident in a year is equal to probability of x equal to 1. It means we have to put x equal to 1 in this PMF or Poisson distribution. So which is equal to e raised to minus 2.5, as it is e raised to minus 2.5 into 2.5 raised to x. So 2.5 raised to x, x is nothing but 1. So 2.5 raised to 1 divided by x factorial. X is equal to 1, so it is divided by 1 factorial. Now e raised to minus 2.5 you will get from statistical table, and that is 0.0821 into this 2.5 raised to 1 is 2.5 and divided by 1 factorial. 1 factorial is 1. Now if you simplify this, you will get 0.20525. They are that number of drivers. Therefore, the number of drivers with one accident, which is equal to capital N into probability of x equal to 1, which is nothing but capital N is 1000 here. Capital N is 1000. So 1000 into this probability of x equal to 1, that is 0.20525, which is equal to 205 drivers. That means the number of drivers who met with one accident in a year are 205. Now second sub question, probability of more than 3 accidents in a year, that is probability of x greater than 3. You can observe here, more than means it is strictly greater than 3. Now greater than 3 means probability of x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6, so on up to probability of x equal to infinity. And theoretically or practically, it is not possible to find the probability up to infinity. So probability of x greater than 3 is nothing but 1 minus probability of x less than equal to 3. 1 minus probability of x less than equal to 3, which is nothing but 1 minus x less than equal to 3 means probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Now we have to put these x values in the PMF. That is 1 minus probability of x equal to 0, that is e raised to minus 2.5, 2.5 raised to 0 divided by 0 factorial, plus e raised to minus 2.5, 2.5 raised to 1. Please consider the second digit after decimal point as raised to, power of. So 2.5 raised to 1 divided by 1 factorial. Next, e raised to minus 2.5 into 2.5 raised to 2 divided by 2 factorial, plus e raised to minus 2.5 into 2.5 raised to 3 divided by 3 factorial. If you simplify this, then you will get 1 minus this simplification, you will get 0.0821. Second simplification, you will get 0.20525. This third simplification, you will get 0.25656. And the last simplification, you will get 0.2138. Then we have to add this bracketed quantity, you will get 0.7577, and that we have to subtract from 1, then you will get the final probability as 0.24229. Now they ask that number of drivers who met with more than 3 accidents in a year. Therefore, the number of drivers with more than 3 accidents are equal to n into probability of x greater than 3. N is 1000 here, and probability of x greater than 3 is 0.24229. If you multiply this, you will get 242.29. So which is nearly equal to 242 drivers. That is, the number of drivers who met with more than 3 accidents in a year are 242 drivers. So in the next class, we will solve the examples on fitting of Poisson distribution. Thank you.